We have been developing in FloatLab a test environment, and we have also built a model scale version of the IEA 22 megawatt turbine on top of a design variant of the Stiesdal TetraSub.
Today is in fact a special day because we added a piece of equipment in our experimental setup, and that's the new wind generator.
We blow up to 5 meters per second in the lab scale, and then in full scale that would correspond to 42 meters per second. So that's sort of a well-boosted hurricane.
It's big, which means we can run very strong winds and have less constraints with respect to the model scale. It provides a realistic wind field because we can control each of the 25 units.
We can actually create sheared wind also with turbulence. This turbulence can vary in space, so you can think like each of these 25 fans can sort of sing their own melody in a choir. A very coordinated melody because they follow the Mann turbulence theory that we can put in here.
We can make a turbulent wind, sort of stochastic variation of the wind velocity, but also in terms of waves. Because here in the DHIs ocean basin, we can run 3D waves with a spreading angle, which means together with the realistic wind, we can have combined realistic waves.
We can also calibrate our numerical models. Very often you want to extend your test campaign with numerical modeling, but then you want to calibrate the model. We operate a range of different models, so we have both sort of quite simplistic, fast models, and then also the very advanced, heavy models. And that's what we work with, both on the aerodynamic and the hydrodynamic side. It turns out when you test in a wave basin, you cannot do the conventional aerodynamic scaling where you preserve what we call the Reynolds number. You have to scale according to the Float model scale law, which means you get relatively low wind speeds. And for that reason, if you look at our turbine, you may see with a sharp eye that it's actually not just a geometric reproduction of the full-scale turbine. So we have done some special aerodynamic engineering.
All in all, this means that the floating offshore wind is tested in a realistic environment. And ultimately, what designer of the whole structure, or particularly the floater, are interested in is to see the behavior of that structure in realistic, still design scenarios.
When the turbines go bigger and bigger, the waves are not changed by that. So actually, if you had a turbine back in the days, the waves would sort of appear larger relative to the turbine than is the case now. We can make big waves in the basin, so it's no problem to make sort of an extreme test. The interesting thing is there is an interaction between the waves and the wind forcing. So the presence of the wind and the rotor will make the motion from the waves in the structure smaller. And on the other hand, the motion from the waves still sort of affects the effective inflow to the turbine. And there's also some control issues. You need to design your controller right. You cannot just use a land-based controller. This is something we can test as well. So we can tune controllers in this setup as well in turbulent wind.
Our ambition now is to get more attention in the market because now we can offer more to the clients in terms of test conditions and also reduced scale limitation in this basin.